tackle the questions regarding the human gut microbiome environment in health and disease, and spanning the themes of the gut microbial resistome and therapeutic use of the bacteriophage. In tandem, Leslie has worked in the biotech sector, gaining a full circle perspective and appreciation for the multifactorial challenges that exist on the continuum between idea, result, and actual product. Leslie joined the Global AMR R&D Hub in February 2021, hoping to combine scientific insight with targeted action to help combat the silent pandemic AMR. So our next speaker is Ralph, who is also a scientific program officer working at the Global AMR R&D Hub Berlin. After his postdoctorate at the Wellcome Trust Center for Human Genetics in Oxford, he joined the Max Planck Institute for Human Genetics in 1998, leading the group mapping and sequencing of the human genome in the framework of the German Human Genome Project, and later coordinated the German participation in the 1000 Genome Project. He was a member of the management team of the IMI UNCTAD project, an international consortium of over 80 scientists that has launched one of Europe's largest collaborative academic industry research projects to develop and assess novel approaches for the identification of new biomarkers for colon cancer. After working in academia, Ralph joined a biotech company specialized in the development of novel processes and technologies and personalized medicine for 1 year. As an expert for personalized medicine and medical technologies, Ralph has been involved in various tenders for the European Commission, evaluating the health theme in the EU framework programs FP7 and Horizon 2020 as a freelance consultant. And he joined the Global AMR R&D Hub in February 2019. So first off, I'd like to extend a big thank you to our two speakers for joining us today and giving this really important talk. Hopefully after this, everyone will have an increased appreciation of how important research and development is in relation to AMR, as we cannot depend on our existing antimicrobials to remain viable due to the current progression of resistance. And the chat will remain open during the talk, so if you've got any questions, feel free to pop them down there, and all questions will be taken at the end of the talk. Now, I'd love to hand over to our speakers. Thank you.
Thank you very much for this kind introduction, and Leslie will start, I think.
Yeah, thank you very much, Angelica. I'll just share my slides with you. You give me a shout if you can see them once I've just done it. Okay.
We can see that, thank you.
Fantastic. Okay, so yeah, thanks a lot for the invitation to speak here today. It really is a pleasure to have the opportunity to be able to tell you about the work we're doing at the Global AMR R&D Hub, supporting evidence-based decision making. So yeah, as Angelica already said, we're going to split the talk into two. The first part will focus on the sort of the who, the what, the why regarding the hub. So what do we actually do? How were we founded? A bit of a background. And then I'll hand over to Ralph, who will tell you about some of the studies and reports that we publish, actually leveraging the Hub's dynamic dashboard. And yeah, more about that later. Okay, so yeah, I think most of you are very much interested in the AMR topic, so you'll be very familiar with the fact that AMR already presents a very serious social and economic burden. I think the current estimates say there's around 700 deaths per year globally, and within the EU alone, there's around 25,000 deaths per year. If we don't act now, there's actually, we'll maybe end up with a scenario where we have around 10 million deaths by 2050. This is serious. There's also the financial impact that we've got to think about in the EU. There's an estimate of around 1.5 billion years per year in AMR-related healthcare costs and loss of productivity. And globally, this figure can go up to around 100 trillion by 2050. I think this is also important to put it into the context that by 2050 it's expected that AMR may cause more deaths than cancer. So to say that the situation is dire is probably a bit of an understatement. So I think it's also helpful to set the AMR situation and context of where we are now in terms of the timeline of antibiotic discovery and commercial use versus antibiotic resistance development. It's been known for a long time that resistance can develop to antibiotics, and we've seen this even with penicillin. So this was famously discovered in 1928, but already upon its initial use, there was starting to be reports of resistance, and this was before the widespread use of it in 1943. When we look forward to the 1960s and the 1980s, this was really the golden age of antibiotic development, surge in the discovery of them. But once we get to the 1980s, there really is a sharp decline in this antibiotic pipeline. You know, during that period of antibiotics, if there was resistance, it didn't really matter because a few other different ones would come along. But this pipeline is kind of stagnated, or is a bit limited at the moment. There's been no new antibiotics classes discovered since 1987. And this is in tandem with increasing reports of antibiotic resistance and antibiotic resistant infections. So this combination of resistance and a limited antibiotic development pipeline has made some commentators state that we're entering a post-antibiotic era, and indeed we may have already reached this state. And this has been really caused by decades of inappropriate use of antibiotics for both humans and animals, creating this state of affairs we have now. It's a crisis that scientists have been warning us about for a long time. It's been in the headlines a lot, you know, revenge of the killer microbes, the drugs don't work, when the drugs don't work. You know, there's been a lot of media interest in this, but there's also a lot of balanced and nuancing reporting out there, which shows what we're doing now and how we can really face the challenges that AMR presents to us. I think I put this article compilation from the Financial Times here, not a paper that I often read, but I found this in there, and it was really interesting because it gives a really broad and nuanced coverage of the different aspects of AMR at the moment, from the financial incentives to causes and effect of increasing global resistance to antibiotics, even just what the pressures doctors are under to prescribe antibiotics, even for viral infections, and also what new treatments are in the pipeline. So I'd really, you know, if you have some time, it'd be worth checking out this link. It's actually quite a nice resource. So I think at the moment we can't talk about anything without mentioning COVID, and it's clear that COVID has also impacted how we think about AMR, from reports of increasing use of antibiotics in clinical settings to triggering public awareness of the seriousness of infectious diseases, and also perhaps the need for investment in systems to respond. There's a really nice quote from Professor Kevin Outterson, who's from Boston University, a very key figure in the AMR community. And he says, today, people understand the social disruption from an untreatable infection due to COVID. You know, we really realize how difficult this can get and how challenging this can get. And it also shines a light on the global health challenges we face and how we can actually approach them. And as Dame Sally puts it, she was, I think she was one of your speakers quite recently. COVID's a lobster dropped into boiling water, making a lot of noise as it expires, whereas AMR is a lobster put into cold water, heating up slowly, not making any noise. And that really puts into a nutshell the silent pandemic of AMR that we're facing. I think this sort of the COVID pandemic and the times we're in now has really ushered in an era of political will for pandemic preparedness, and this has been a really important milestone even for AMR, I think, because if there's political will to get things done, this will happen. And we've seen this with COVID: concerted efforts, collaboration, and of course money that's been thrown at one of the biggest challenge we faced in a long time. So in terms of where we are now and what are the unmet needs that we really need to solve in AMR, I think in recent years, there's been really a number of important milestones that we've reached. In 2013, the UK had the G7 presidency. Germany had it in 2015. And during this period, we saw a lot of movement in terms of concrete steps towards facing the challenges of AMR. The UK commissioned a review of antimicrobial resistance, and this was chaired by Jim O'Neill. And this actually provided recommendations for action. So I think the final report was published in 2016. There's a number of other reports out there, I think from 2014 onwards. In 2015, the World Health Organization was commissioned to create a priority pathogen list. This was during the German presidency of the G7. And so it published the priority pathogens list for R&D of new antibiotics. So they went about identifying a list of bacteria that were the biggest public health threats in terms of emerging resistance, and then matched this list against which treatments were available and which ones we needed. And in doing so, they really managed to generate a priority list for research and development. So they spotted the gaps and information that's really been welcomed by a range of key stakeholders from across the public and private domain, so industry as well, of course. And this was really a really clear milestone in mapping unmet needs in the fight against AMR. We set priorities there. So the list comprises 12 families of bacteria. These are the ones that pose the greatest threat to human health. And it highlights in particular the threat of gram-negative bacteria that are resistant to multiple antibiotics. The publication of this first list coincided with the G20 Leaders meeting in that year, which was held in July 2017. And I mention this because this has a lot to do with the hub, and this is where we were sort of born from. We came from this meeting and the sort of concrete steps that they wanted to take to tackle AMR. And when I mean we, I mean the Global AMR R&D Hub. So yeah, so this meeting was the G20 Leaders Declaration in 2017. It's called Shaping an Interconnected World. And it included a very comprehensive health track and highlighted the importance of combating AMR, including tuberculosis, and on building resilience into our health systems. So yeah, as part of this, there was a call for a new international R&D collaboration hub to maximize the impact of existing and new antimicrobial basic and clinical research initiatives, as well as product development. And this is where we come from. Yeah, so following this call, we established the Global AMR R&D Hub, and we are a global partnership working to improve and enhance R&D activities and policies across the One Health spectrum. We launched in around May 2018, but we aren't actually operational until January 2019. And our mandate is really to foster global priority setting and evidence-based decision-making. So we can allocate resources for AMR R&D, including identifying gaps, overlaps, and also potential for cross-sectoral collaboration. We're steered by a board of members, so that the members come from 17 different countries, the EU, and also 2 different foundations. So this is the Bill and Melinda Gates Foundation and the Wellcome Trust. And the countries range from Australia, France, United Kingdom, of course, United States, Spain, Turkey. So we've got quite broad coverage across multiple continents. And importantly, we also have observers, which allow us to have this real One Health perspective. So our observers are the World Organization for Animal Health, the Food and Agricultural Organization, the OECD, so the Organization for Economic Cooperation and Development, and also the WHO, so the World Health Organization. And the day-to-day activities of the hub are run by a small secretariat. It's based in Berlin, and this is what myself and Ralph are part of. There's 5 of us in Berlin working on this. And I think what's important to really point out is that we have a uniquely global setup. As I said, we span 17 countries, multiple continents, but yeah, there's still some gaps there. We don't have, we're still lacking a bit of representation from certain countries, for example, in the African continent. But we're working on plugging those gaps and providing a very broad range representation. So just in case, we've mentioned One Health quite a lot, so I just wanted to make sure that anyone that wasn't familiar with this term, that I can give a definition here. And so yeah, I think it's clear that human, animal, plant and environmental health are very closely connected, and One Health really recognizes the connection and integrates a very holistic approach to involve experts and relative disciplines from all relevant sectors and industries. So that's the sectors are environment, animal, plant and human. So we have a broad coverage of these sectors and also the different approaches that we use. So we come together in a One Health approach. So that's kind of, I just wanted to give you a bit of history and a bit of background and how we were actually established. And now we're want to go on to a bit of actually, what do we do? What does the Global AMR Hub actually do? So on a day-to-day basis, our work is aligned into 3 strategic pillars. So the first pillar is focused on guiding and supporting evidence-based decision making. So we actually collect information from Global AMR R&D, and this is from both public and private sources. And this is R&D across the One Health spectrum and across the entire value chain and technology sectors. And using this information, we can provide analysis, recommendations, and we always are trying to reach this at the policy level. In pillar 2, we really focused on enhancing collaboration and coordination. So we really want to promote cross-sectoral and cross-disciplinary approaches and help different sectors communicate and engage with each other and actually foster that greater mutual understanding. So, speaking the same language in a sense, so we can understand each other. And then pillar 3, that's very much focused on promoting awareness, knowledge and visibility. So we want to keep AMR on the agenda. We want to make sure that it's on the agenda across all sectors, the highest political levels. And we're also advocating for increased and more sustainable investments into AMR R&D, again, at the highest political levels. In the first year of the Hub, we've been really concentrating on pillar 1. So this work that really goes into collecting the information and being able to provide analysis and recommendation. And that's where the dynamic dashboard comes in. So this is this unique online platform of consolidated information on AMR R&D. So we've been in this very operational, technical setup phase. And as we move forward, we can really start to leverage the information we gain from the dashboard and focus more efforts across the 3 pillars much more evenly and intensely. So yeah, this is our landing page for our dynamic dashboard, a Global AMR One Health resource. And what we do there is continuously collect and present information on global investments in AMR R&D. There's 3 different galleries. So first of all, we have the investment gallery where we present all our AMR R&D activities and investments across the One Health continuum. The second gallery is the pipeline gallery, in which we display all products in clinical development and even those that have been recently approved. And this information actually is collated from the WHO and also the Pew Charitable Trust. So they have their own dashboard that we can combine that data from. The third gallery that we have is called the incentives gallery. And this is actually focused on what we are actually doing to fix the challenges hindering the development of and access to priority antibacterials. And this is focused on human health. What we've been doing is building up the data in stages. So we started around a year ago adding data to the dynamic dashboard. So human bacterial infections were added in March 2020, animal health in July of that year. We added the antibacterials pipeline and incentives gallery in around August, and data on human fungal infections in December 2020. And just today, we've actually launched our plant and environmental data. So we're very excited. This is a great day for us because we are now truly One Health. Overall, however, I think the dynamic dashboard really is a versatile platform that can be used to support the work of a variety of stakeholders. So I'm going to now take you through into each of the galleries. I'll try to not get into too many details as we go through. So the first one's the investments gallery. So just to sort of, you know, maybe accentuate this a bit more, that today is the launch of the plant and environmental health projects, and we're actually a truly One Health platform today. Overall, we have data from 11,000 projects, over 11,000 projects that are funded from 195 different funders globally. And this is funding that is in value of 8.14 billion US dollars. So we're really excited to get to this stage where we've actually got so many projects in our database that we can actually leverage to gain insight. So yeah, so I have to tell you again, it's our first birthday here, and I just want to show you the projection that we've had over that year. I think we started off with around 4,000 projects, and over those 12 months, we've now got around 11,000 projects. So we're very happy to be at the stage we are. So getting into this gallery. This gallery is presenting basic and applied research projects and investments from public and private funders. So these are philanthropic funders, the private ones. Usually we've not got a lot of data from actual industry or private funding agencies at the moment. So as I said, we cover all One Health sectors now: plant, environment, animal, and human. And the information that we collect really we're really trying to support AMR action plans such as surveillance, operational, stewardship, infection prevention and control, and policy. So the projects sort of span that continuum, and it also covers the entire research and innovation value chain. So there's treatments, prevention measures, products, diagnostics, promotants, and also other products such as surface disinfectants. And to do this, we've actually got to read every abstract from the funded projects and categorize each project according to these different research areas. So whether it's a plant or environment, whether it's a therapeutic or diagnostic, etc. And so the investments that we are actually presenting are only from those that were active on the date of the 1st of January 2017 and onwards. So ones could start, of course, after that, but that's the earliest date that we include in our platform. Just want to highlight this map here as well, and that sort of gives you an idea of where the funders come from. So we've got quite a density in Europe and North America and Canada, but we can see there's quite a lot of white space in the African continent, and we really want to try and plug those gaps and find more information on the funders within that region, and also provide more information on institutional and privately funded R&D projects. So we gain a more comprehensive and fuller picture of the AMR R&D landscape. I just want to quickly show you, within the different reports of the investment gallery, we can actually drill down into more specifics. So here is an example of a gallery that could be very interesting for both ministries and industry, as it provides an overview of investments that actually target product development. So we can see where the funding is going to. So it's not just about who's funded, but who's receiving the funding. And we can also analyze funding data according to different pathogens and compare this to the different priority pathogens list. So as I mentioned, we've combined a list from different sources, so from WHO, CDC, and also includes the recent updates from the Indian Global Priority Pathogen list. And so on this report, we can also divide the product development into different stages. So for example, therapeutic or vaccine. So we know what type of products are being researched and or developed, and which bacterial pathogens, and where is that funding going to. So we're going to leave the investments gallery and now jump into the pipeline gallery. So that's the antibacterials in clinical development. And this gallery really shows the antibacterial products in clinical development or products that have recently been approved. And it really complements information in the investment gallery and also the incentives gallery, which I'll show you next. And so the information that we present here is an amalgamation of the information that the WHO and the Pew Charitable Trusts have gathered and analysed. And the goal of this presentation is really to provide a consolidated overview of the existing pipelines and to really provide the level information, a very clear and with clear actionable takeaways for global policymakers and stakeholders. At the moment, we're updating our information in this gallery based on the new reports from the WHO and also the Pew Charitable Trusts. And yeah, this was the report that was published on the 15th of April. And this shows that it really relates to what we're showing, of course, in the pipeline gallery, that the development pipeline just doesn't include enough new antibiotics to protect patients. And that's especially from gram-negative pathogens and WHO bacterial priority pathogens. There's only 43 antibiotics in clinical development, and only 26 of those are targeting the WHO priority pathogens. I think Peter Bayer, he's the senior advisor for AMR at WHO, and he states the pipeline is insufficient to actually counter the rising resistance against these priority bacteria. And this is really echoed by the Pew Charitable Trust, who published their report in March. And they say it's just clear that there's just too few drugs in development to meet current and anticipated needs. Our hope is that researchers or policymakers and other innovation stakeholders will utilize these findings that we kind of consolidate in the dashboard to track the antibiotics portfolio. And we hope that could also inform new ongoing research and as well as policies that will help stimulate the pipeline and actually ensure sustainable access to new drugs. So now we're going to move to the third and our last gallery. This is the incentives gallery. And what this does is really display, track, and on this dashboard, the incentives being implemented around the world, and that aim to improve the function of markets and the broader R&D ecosystem in general, that are actually responsible for the development, distribution of the therapeutics that are targeting these priority human bacterial infections. Our hope is by displaying this information in a very key, very clear, and providing the key points that we provide information across the whole value chain, early stage discovery and translational research to distribution and marketing. So we hope that provides a very global snapshot of the status of the current development pipelines here. So I think it's important to note as well that although innovation is shown in our gallery, in this incentives gallery, access and stewardship are also key factors. So we need to make sure that new antibiotics are used responsibly and are made accessible to the patients who need them. And I just wanted to put this in because I wanted to highlight that these three things go together to ensure there's a sustainable supply of antibiotics. So please do check out the CarbX website where this image comes from, and also I've put a link in there to the original article from Hoffman and Audison. It was published in 2015. So I'm going to stop there and let Ralph take the floor and provide a summary and a bit more insight into our reports and analysis that we have ongoing at the Hub. So yeah, thanks very much, and over to you, Ralph.
Yeah. Thank you very much, Leslie. So I would like to present a little bit what we have done with the data. So an effective research policy making and financing of AMR research required a strong evidence base, and there we come into play, the Global AMR R&D Hub, but also our main tool, the dynamic dashboard, where we really collect information from a really wide range of data sources, like Leslie already mentioned. So we have data from 195 funders in the moment, and it's ticking. So every week we get information from additional funders and incorporate them into our dashboard. And this dynamic dashboard provides a centralized and comprehensive source of data that aid to the identification of gaps, but not only gaps, but also opportunities, and leads to avoidance of duplication, and therefore for better coordination and research prioritization of AMR research and development activities. And it contributes to the priority setting of within the G20 countries, but not only within the G20 countries, but also beyond. So that's what we called G20 initiated organization, but we are not a G20 organization. So we also have information from, so we have board members which are not G20 countries, and also we have, of course, the data from outside G20 countries. AMR, as Leslie really nicely described, is a really global threat, and therefore we need a global coordination and global cooperation. So that is one of our strengths compared to other initiatives, that we are really global and covering all continents except in the moment Africa. This is a real weakness in our setup. And we also applied a really holistic approach, and this holistic approach is required for effective control and prevention of infectious diseases and AMR. Therefore, this One Health concept was already in our mandate and in our mission from the beginning, so that we believe in a collaborative, multi-sectoral and transdisciplinary approach. And in this atmosphere, the Global AMR R&D Hub was launched following the call of the G20 leaders, and the main task is really to address these challenges and improve coordination and collaboration in the Global AMR R&D field using a One Health approach. Next slide, please. So in November last year, we published our first annual report, and we did comprehensive analysis of all the data we had in our database, and tried to draw some conclusions out of it, or we drew some conclusions out of it, which we submitted to the G20 fora. And one important finding we saw is really that research across all the pathogens really nicely aligns well with the priority ranking of the bacteria of the priority list developed by the WHO and the US CDC. But one of the recommendations is, one of the findings is really that we need a lot more support for late stage clinical development that is necessary. But also we need not only more support for this late stage clinical development, but we need also more support from more countries. So next slide, please. On this slide, you can see what we call the funding distributor. So we define a funding distributor as an organization which receives funding by various funders and uses funds to support projects and programs respectively. A funding distributor is therefore a recipient of funding, but also a funder themselves. And the first two examples we included in our dashboard are the CARP-X and the GARD-P organizations. They receive funding from these ministries, which are listed on the left, or not only ministries, but also foundations. And but what I wanted to, and I must say, CARP-X is really funding projects, 82 projects in the moment in the early stage preclinical and phase 1 environment, whereas GARD-P is also not only supporting early but also late stage projects, which are could be until phase 3. But what I wanted to show really with this slide is that we always have only the same suspects funding research into our AMR. You always see funders from the US, from the UK, then from Germany, and then only a very few others. So for this now we are really happy that Japan joined and put in money into GARD-P, but also let's say Switzerland and the Netherlands, and then there are always all the other funders. They have only very small amounts of funding into these really important pots. And so one really recommendation from the Global Hub is that we also need a lot more country coverage, that countries commit themselves to fund research in the area of AMR, and also using these funding distributor who are funding product-related projects in the field of AMR. Next slide, please. I think also, let's say, more countries involved in what we call pull incentives. This is what Leslie already explained. Pull incentives are really incentives to overcome this broken market for antibiotics. There's a nice incentives pilot project started in the UK, which is called the Netflix model, because people can subscribe to get, it's now difficult to explain. In principle, there's a D-link between a volume of antibiotics which are on the market, which are sold, and the value of antibiotics, because the value is much higher than the prices you can get on the market. And for this reimbursement for the pharma industry, there are now different models tried out, and one is one in the UK, the other one is in Sweden. But also here, and there's another model in Germany, and one is just probably approved as a Pasteur in the US. But also here, these are already the same countries we trying to be committed to the AMR, and we need a lot broader coverage with other countries also in the area of pull incentives. Also, more should be done to increase cooperation and enforce a concerted action on the Global One Health R&D response. And this is one of the major goals where the Global AMR Hub is now playing a role. And also the industry should be encouraged to contribute to their, let's say, contribute their data to the dynamic dashboard. So in the moment, we have only aggregated data from the industry, which are not really very meaningful for us. So, and I will shortly touch on two reports we did. One is on public and philanthropic investment in AMR R&D related to fungi. That is the second one I only very shortly show 1 or 2 slides, and then there's another report which is not published yet on international and coordination funding in the AMR R&D field. Next slide, please. Next. So partnership and coordination. So AMR is one of the most complex public health threats. The need for joint and coordinated R&D activities where countries combine their resources, but also their expertise to be prepared for dangerous infections and for combating the silent pandemic of AMR were expressed by several organizations, including the G20 and the WHO. And our dynamic dashboard now allows an analysis of the current level on international cooperation, which leads to hopefully to an exchange of best practices. What I show next is that really are based on the data as of January this year. So it's not from today the data, but at one time we had to freeze our data, and this is really from January. And this analysis which I present to you will be repeated with the current data set after the summer break second time, and will be published in the next annual report. Yeah, next slide, please. So what you can see here, so in our annual report in November last year, we looked at international coordinated funding, and we defined it in the way that every time when a funder funds a research organization in a different country, it was identified or categorized as international funding. And by this, we got a split between 17 and 30%. 30% was internationally coordinated, and 70% is what we call domestic funding, where the funder funds research organization in their own country. And because of most of these projects are really funded by the European Commission, you can see here in the list of countries receiving these fundings, mainly countries from the European Union, including UK, of course. And then we thought, okay, this is probably not, we have to broaden our definition, because this is not only when a funder funds in a different country, but also we now included globally operating organizations such as the Wellcome Trust or the Bill Gates Foundation as international coordinated funding, but also the Repair Impact Fund from Canada or the Fleming Fund from the UK, and included funding distributor, which I showed you before, the GARD-P and the CARB-X organizations, but also all ERA nets and joint programming from the European Commission were included in here. And in addition, there are some bilateral and trilateral partnerships included here. And by this, we increased the number of projects we analyzed to 2,000, which is not nearly 45%, but if you look at the investment, not on the number of projects, then what we consider now as internationally coordinated funding reached 45%, other nearly 50%. And so, of course, because the European Union has such a large part of it, still most of the countries are European countries, but you see number one is now United States, but also there's, I think, South Africa in the list of funding, the countries receiving funding from other countries. Next slide, please. And if you look at or analyze the projects which are internationally coordinated, then we see really a shift from, if you only look at the top bars, from basic research, which is the blue bar is all projects. The basic research is nearly 30%, and in this international coordinated funding, this number decreased to half. And so we can really say that in the international partnerships, the focus is more towards product-related research. That means therapeutics, preventives. Preventives are mainly vaccines, and that we can see in this international partnerships. And if you only look at funding from one country to another, which is not coordinated, but only by if a national funder funds a research organization in a different country, there are only very, very few countries doing this. That is the United States, Switzerland, it's the UK, of course, and Canada, and then a very, very few other countries. So let's say an uncoordinated funding of foreign research organizations. And we believe that in the field of infectious diseases, that is very important, that more countries really also fund research organizations, let's say in low and middle income countries, also outside their own country, without any coordination. But what we really see is that funders are only able to fund research organizations outside their own country if they partner up with other funders in bilateral or trilateral partnerships, or even in if they fund, let's say, organizations like CARP-X or GARD-P, or probably in the future the AMR Action Fund. Next slide, please. So that is in principle, is summarized what I just said. So we use the data from January this year, and what we really see is that if you compare all funding with the international coordinated funding, that all funding the project are, the budget of the project are much smaller than the projects receive much higher volume of money when they do is funded within partnership. And also the product related research is more in the focus than with the domestic funding. So if you only look at bilateral partnerships, this is only a small portion of the international partnerships. We see a lot of these partnerships funds really the other sectors than humans. So for example, the animal health projects. And here, even if they fund more animal health, the percentage of product related research goes up by far over 50% if you only look at the bilateral partnerships. Next slide, please. And this is also shown here. This over 50%. That's all. Nearly a lot of this funding goes really to therapeutics, preventives, which is vaccine research and diagnostics. Next slide, please. Next slide. This is only on another report which we published. I only wanted to show very short, and also the top bar, that in the area of fungal infectious disease research, most funding goes really to basic research, and there's a huge gap and lack in product-related research. You can see therapeutics, preventive, and diagnostic get only a very small fraction of the funding. Even if we could consider the fungal fungal resistance will become a very urgent problem in the future, and probably is already in low and middle income countries like Africa. But on the left, right-hand side, you can see that are also here only a very few funder countries are funding research into fungal resistance, and these are the same suspects like before. It's the United States, the European Union, the UK, and then this 20% are all other countries in the world, and there's no country with a higher part than 3% in this area. So this fungal related research is really there's a lot. Yeah, it has to catch up a lot. So next slide, please. So this is only I wanted to mention. So there was a collaboration between the PAR Foundation, this is the Foundation to Prevent Antibiotic Resistance, it's a Swedish foundation, and the student group in Cambridge, the Students for Global Health, and they teamed up to deliver an AMR training program, which calls Become an Antibiotic Ally Against AMR. And the nice thing is, we are also have a collaboration with the PAR Foundation, and in principle, they ask the students that they use our dashboard and our data to come up to inform the next calls from the PAR Foundation. So the students came up with a did a gap analysis with our data and informed the PAR Foundation what they should fund next. And just today, we got, this is another nice example, we got an email from the Australian government, from the Health Directorate. They said that they're also using our dashboard to inform their AMR strategy in Australia. Next slide. Yeah, and one of our, let's say, main tasks is really to keep the AMR field high on the political agenda. And just today, it's still running, and the high-level interactive dialogue on antimicrobial resistance at the UN, and you can follow this panel discussions here at the UN Web TV, and I think it's on the whole night, or at least the whole evening. So, and also Sally Davis gave just a presentation before we started here with our seminar. Next slide. So this is only an impression, a visual representation of the depth of the topics of the projects we collected in our dashboard. So we did based on all the abstracts, word cloud shown here. And next slide, please. And I would like to thank you for your attention and you can please follow us on Twitter and on LinkedIn. And here are also our addresses for our website and from our dashboard. And if you have any feedback to our dynamic dashboard, please go there, play around with the data, and send us feedback so that we can improve our tool. And thank you very much for your attention. I'll stop here.
Well, thank you very much for your talk. It was really interesting and insightful. I think it really gave a perspective into AMR that perhaps not a lot of people be aware of. So yeah, I just like to say thank you for giving this talk. I did check the chat. I don't think there seem to be any questions, unfortunately, but yeah, I'd just like to say thank you now. And I suppose if you have any other comments you would like to add or mention, I think we'll be rounding up the talk now.
So from my side, just thanks a lot for the invitation. It's been nice to be here, and I hope we, keep in touch. Follow us on Twitter. Look at, like Ralph said, look at the dashboard. Yeah, it'd be good to get you guys' feedback, what you think of it. It's great. Thanks.
Thank you.
Thank you.